Okay, so think about how much time we spend indoors. It's most of our lives, right?
Pretty much, yeah. The vast majority.
And lately, well, with everything going on, we're all thinking a lot more about airborne germs, pathogens,
Hmm.
the actual air around us.
Absolutely, and that's really pushed technologies like germicidal UV or GUV back into the spotlight.
Hmm.
People are looking for ways to clean indoor air.
Right, GUV. Using UVC light for disinfection. It's got history, hasn't it?
It does, yeah. It's been used, effectively against things like measles, TB, so it definitely can work on viruses and bacteria floating in the air.
But here's the thing, isn't it? If it's powerful enough to zap pathogens, could it be doing other things to the air? Maybe things we don't want.
That's the crucial question. You've got this high-energy UVC light, and it absolutely has the potential to react with other stuff. Chemicals in the air, things on surfaces.
And those reactions might create, what, new pollutants?
Potentially, yes.
Yeah.
Byproducts like ozone or certain types of volatile organic compounds, OVOCs, maybe even really tiny particles.
Okay, exactly. And that's what we're diving into today. There's this recent study, a really specific one, that looked right at this question.
Yeah, it tried to see what happens to indoor air quality when you run different GUV devices. And importantly, they did it in a real-world kind of place.
Not just a clean lab.
Exactly. They were in an aged care facility in Melbourne, Australia. Unoccupied, but still a complex, real environment.
Over a whole month, measuring ozone, VOCs, particles, seeing what changed when the GUV was on.
Mhm.
So if you're curious about what's really in the air you breathe inside and how these air cleaning technologies might be affecting it, good or bad, you're definitely in the right place.
Okay, let's get into it.
Let's unpack this research. So setting the scene a bit more, GUV is UVC light. And this study looked at two main kinds.
Correct. First, there's the sort of more established type, GUV-254, that typically uses mercury lamps. Wavelength is mainly 254 nanometers.
And that one's usually put up high, right? Upper room.
Yeah, exactly, because 254 can be harmful if you're exposed directly, skin and eyes. So you put it near the ceiling, disinfect the air circulating up there away from people.
Okay. And the other type?
That's the newer GUV-222. Uses what are called krypton chlorine excimer lamps. Main wavelength is 222 nanometers.
And the thinking there is it's safer, less harmful.
That's the idea, yeah. Potentially less damaging to skin and eyes, which opens up the possibility of using it for like whole room disinfection, treating the air and surfaces everywhere, even with people around.
Gotcha. Now, why the worry about air quality impacts? You mentioned reactions.
Right, so the physics of it. UV light below about 242 nanometers, like the 222 nanometer light, has enough energy to actually break apart oxygen molecules, O2.
Ah, and that's how you get ozone, O3.
That's exactly it. It's called photolysis. So GUV-222 can make ozone, and UVC in general can also break apart other molecules, creating these really reactive things called radicals.
Like little chemical sparks, you said?
Sort of, yeah. They don't last long, but they react quickly with whatever's around other VOCs surfaces.
And that's where you might get the unwanted OVOCs, or maybe those ultrafine particles, the UFPs?
Precisely. And we've seen hints of this before, in lab tests, even some field tests. Sometimes you see significant jumps in these things, sometimes not. Depends on conditions.
Which makes this study in the aged care facility really useful. It's a real place.
A month long, down in Melbourne during their winter. So you get real-world variations in outdoor air, too.
And the room itself, pretty standard.
Yeah, about 159 cubic meters, typical size. They tested ceiling-mounted GUV-254 units and some freestanding GUV-222 ones.
And the ventilation, this seems key. They tested two different setups.
Crucial point, yes. They ran tests with the building's mechanical ventilation on the HVAC system. That gave them around 3 air changes per hour. Pretty decent.
Okay.
And then they ran tests with the HVAC off, just natural ventilation, relying on leaks and cracks, basically. That dropped the air exchange way down to a 1 air change per hour.
Wow, big difference. So less fresh air coming in, less stale air going out in the second scenario.
Exactly. And that difference in ventilation turned out to be huge.
So the main goal was just to see, did running these GUVs actually change the levels of ozone, OVOCs, or particles compared to the baseline? And were those changes, big enough to matter compared to health guidelines, or just the normal background fluctuations?
That's the core question they were trying to answer in this specific realistic setting.
All right, let's get to the findings. What was the headline, the big picture result?
Well, the main takeaway, honestly, was that while the GUV devices did have some small measurable effects, the impact of just the ventilation rate and what was happening with the outdoor air pollution coming in, those effects were way bigger.
Really?
Yeah. In fact, just turning the HVAC off, having that lower ventilation rate, that actually had the biggest negative impact on the background air quality, even before they turned any GUV on.
Wow. So the basic building system, how much air it moved, mattered more than the fancy UV lights in this case.
In terms of the overall pollutant levels, yes. That was a major finding.
Okay, that's significant. Let's break it down, though. Start with ozone. We said GUV-222 could potentially make it. What did they find?
Okay, so first, the GUV-254. As expected, because it's mostly 254 nanometers,
Why?
above that ozone-making threshold, they didn't really see any distinct ozone increase linked to it.
Nothing noticeable.
They did note a tiny, statistically significant positive blip, less than 0.2 parts per billion. But honestly, that's so small, it's almost within the measurement fuzziness. Practically speaking, GUV-254 didn't add ozone here.
Okay, good to know. GUV-254 looks clean on the ozone front. What about the GUV-222 then?
That one did seem capable of increasing indoor ozone, but the effect was pretty subtle and kind of inconsistent.
How so?
They could only really pin it down, clearly see the increase during times when the outdoor ozone level happened to be really stable, made it easier to isolate the GUV's contribution from the background noise.
Okay, so when outdoor air wasn't fluctuating wildly.
Right. And during those specific stable periods, they calculated that the GUV-222 units were producing ozone at a rate of about 670 micrograms per hour.
Okay, 670 micrograms per hour. And in that room size, what did that actually mean for the concentration people would breathe?
It worked out to an increase of less than 1 part per billion, maybe around 0.7 ppb on top of the baseline, which was around 7.5 to 8 ppb during those tests.
Less than 1 ppb increase from GV-222. How does that stack up? What's normal indoor ozone or the health guidelines? Give us some context.
Sure. So in this study, the average indoor ozone was around 4.5 ppb with the HVAC running and about 3 ppb with it off. So an extra 0.7 ppb is, pretty small compared to those background levels.
Okay.
And then you look at health guidelines. The WHO has a peak season guideline of 50 ppb. So less than 1 ppb is obviously tiny compared to that.
Right. And you mentioned other studies sometimes saw bigger increases.
Yeah, some previous work reported maybe 4 to 11 ppb increases. But often those were done in much smaller chambers or rooms. Same amount of ozone produced in a smaller space gives you higher concentration, right?
Makes total sense. Dilution is key. So if the GUV-222 effect was small and GUV-254 basically zero, what was driving the ozone changes they saw inside?
This is where it gets really interesting about the outdoor air connection. The dominant factor, by far, was ozone coming in from outside.
Really? Just leaking in?
Yep, especially when the mechanical ventilation was running. The study estimated that changes in outdoor ozone caused indoor ozone to fluctuate by about 6 ppb. Compare that to the roughly 0.7 ppb from the GUV-222.
Wow, so almost 10 times more impact from outdoor air fluctuations than from the GUV device itself.
Pretty much, yeah. Even just having the HVAC on versus off made a difference of maybe 1 ppb on average. But the outdoor connection was the biggest driver of variability they saw.
Okay, so for ozone, outdoor air and ventilation were the main story. GUV impact was minimal, especially for 254.
Got it. Let's switch gears to VOCs, specifically the oxygenated ones, OVOCs. Remind us what those are.
Right, OVOCs, basically VOCs that have reacted with oxygen. Common ones indoors are things like acetic acid vinegar, smell methanol, acetaldehyde, acetone. They come off building materials, furniture, cleaning stuff, even us.
And what did the study find about GUV's effect on these chemicals?
Again, the effects were pretty small, but they were definitely measurable and statistically significant. And again, it was mostly linked to the GUV-222.
A whole room one.
Yeah, they saw small bumps in several OVOCs, especially acetic acid and methanol. When the mechanical ventilation was on, the typical increase after an hour was maybe half a ppb, up to 1 ppb for those two.
Okay.
A bit higher under natural ventilation, maybe a couple of ppb after a few hours, but still small numbers overall.
And the GUV-254, the upper room one.
That one seemed linked only to tiny increases in acetaldehyde, like 0.01 to 0.12 ppb, barely a blip. Okay, so GUV-222 adds a little bit of these OVOCs, GUV-254 much less. But here's the really interesting part you hinted at earlier. How they think it was happening. It wasn't the obvious way.
Exactly. This was maybe the most surprising finding. The evidence strongly suggested these OVOC increases were not mainly happening because of reactions in the air itself.
So not like UV makes ozone, ozone reacts with VOCs in the air. Boom, OVOCs.
Doesn't look like it. The amount of OVOC increase didn't really track well with the measured ozone levels.
No.
And interestingly, when they deliberately added extra VOCs into the room air, it didn't really change how many OVOCs were produced compared to the control test without the added VOCs.
Huh. So if it's not happening in the air, where is it happening?
The evidence points strongly towards surface chemistry.
On the surfaces, like the floor, walls.
Exactly. They found a really strong correlation between the OVOC levels and the room's temperature and humidity, but only when the GUV-222 was running. This suggests the UV light was hitting surfaces, like the linoleum floor perhaps, and either causing those surfaces to release more OVOCs or maybe driving reactions on those surfaces.
That makes a lot of sense, especially with the GUV-222 being whole room irradiation. It's shining directly on the floor and lower walls. Precisely, whereas the upper room GUV-224 is mostly just hitting the air high up. It's not really illuminating the main room surfaces in the same way.
So the implication is huge. It means the design and placement of the GUV unit, whether it shines on surfaces or not, might be more critical for these OVOC byproducts than just the UV wavelength itself.
That seems to be what the data suggests here. Direct surface irradiation seems linked to this effect. Again, just for context, these OVOC increases they saw, like 0.5 to 2 ppb maybe, that's really small compared to health standards for workplaces, which are often hundreds or thousands of times higher.
Right, perspective is important. Okay, last category, ultrafine particles, UFPs, the really, really tiny ones. Where do those normally come from indoors?
Oh, lots of places. Cooking's a big one, cleaning products, burning candles, and they also drift in from outside traffic industry.
And the theory was that GUV could potentially make these if the chemistry was right, like if reactions created stuff that then clumped together out of particles.
Yeah, if you had the right precursor gases, GUV-driven chemistry could potentially lead to new particle formation.
What did this study actually find? Did GUV make more UFPs?
Nope. In this specific month-long study, they found that neither GUV-222 nor GUV-254 use was significantly linked to increased UFP concentrations.
Really? No particle increase at all?
Not that they could clearly attribute to the GUV devices, no. Particle levels in the room definitely went up and down, but the changes they saw during GUV operation times were basically within the normal background noise. No distinct GUV on particle spike.
Okay, so if GUV wasn't making particles, what was making the UFP levels change in that room?
The two biggest factors were, again, the HVAC system and the outdoors.
How did the HVAC affect particles?
Turning the HVAC on actually lowered the UFP levels.
Oh, interesting. Why?
Likely two reasons. The filters in the HVAC system were catching some particles, and the increased air movement probably caused more particles to just bump into surfaces and stick their deposition.
Right. And the outdoor factor.
Outdoor wind speed seemed important,
Right.
probably influencing how many particles were getting pulled in from outside.
Good to know. And were the particle levels generally high in this facility?
Not really. They mentioned the indoor UFP concentrations generally stayed below what the WHO considers high, which is around 10,000 particles per cubic centimeter. So the baseline wasn't excessively polluted with particles to begin with. And it's worth remembering, like you said before, other studies have seen UFP increases with GUV sometimes, but often under quite different conditions and maybe really low ventilation or labs with high levels of specific chemicals added, different context.
Okay. So let's try to pull this all together. For you, the listener, trying to get a quick handle on this, what are the main messages from this specific piece of research?
I think it gives us some really valuable real-world context. It shows that, okay, yes, in this particular setting, unoccupied aged care place, decent ventilation options, GUV devices can produce some byproducts. A tiny bit of ozone from GUV-222, small amounts of specific OVOCs, again, mainly from GUV-222, likely via surface reactions.
What?
But the overall impact of those GUV-produced things on the total air quality picture was generally pretty small compared to much bigger influences.
Like just running the ventilation system properly.
Exactly. Good ventilation and the quality of the air coming in from outside, those seem to be the dominant factors controlling levels of things like ozone and particles in this study.
And filtration, presumably, helping with the particles too?
So it really highlights that managing indoor air quality is about the whole system. Ventilation and filtration are still fundamental.
And for GUV specifically, the study flags some important details to consider.
Yeah, the nuances matter. Knowing the 222 millimeter can make a bit of ozone, even if it was small here. And maybe most interestingly, that the way you deploy it, especially whole room versus upper room, shining on surfaces versus not, seems really key for those OVOCs produced from surface chemistry.
That surface chemistry angle feels like a big piece of the puzzle.
It does. It suggests Maybe device design, material choices in the room, and where you point the light could be really important for minimizing any unwanted chemistry, perhaps just as important as the UV wavelength itself.
And we should remember, this was an unoccupied space.
Crucial point. The researchers mentioned this too. Put people in the room, add furniture, activities. You add more chemicals, more surfaces, more complexity. People emit VOCs, skin oils react with ozone. It gets way more complicated.
So recapping the core findings one last time, GUV's impact here. Small compared to ventilation and outdoor air, ozone increase. Tiny, only really seen with GUV-222. OVOC increase. Small, mainly GUV-222, linked to surface reactions. Particles. No significant increase seen from GUV in this study.
That sums it up pretty well, based on their data. It adds specific, real-world measurements to the ongoing discussion about how best to use these technologies.
Okay, so this gave us a great snapshot inside an unoccupied building. It really leaves you thinking, though, what happens next? When you do add people and all their associated stuff and activities, how do all these interactions, the UV light, the air chemistry, the surfaces, the people themselves, how does it all truly balance out in a busy, lived-in space?
Yeah, that's the complex reality.
What's the ultimate sweet spot, the right mix of ventilation, filtration, maybe GUV, maybe other things, to actually nail both goals? Killing the germs effectively and keeping the air genuinely healthy and clean to breathe still feels like an open question.
Definitely requires looking at the whole picture, all the interacting parts.
Absolutely. Well, thanks for joining us on this deep dive into germicidal UV and indoor air quality. Lots to think about.